Okay, this is Johnny on the Spot, a science reporter for the Real News Network, and I'm here with Professor Home Run, and he said he stumbled upon some stuff that he wanted to make a video on, and he said this is very fascinating, and he's saying this is going to be slightly a long video because we're going to cover an entire state fair, science fair project for high school students, and so watch this all the way through. It's going to hit a bunch of different issues. But if you watch this video, you can use it as the foundation of a really solid science fair project. Isn't that right, Professor Home Run?
Yes.
Okay, what you were pointing out to me, that the climate science doesn't really follow the scientific method. The normal scientific method is you research, you form a hypothesis, you develop experiments and you collect data, then you draw conclusions, right? Well, climate science kind of circumvents that. What they do is they kind of replace experimentation with computer models. And anyone knows anything about a computer model, you're telling me, you can make them say anything you want.
Yes.
They also don't have a falsifiable hypothesis, right? That's what you're telling me?
Yes.
And what we're going to show you in this video is how you can form falsifiable hypotheses and then go test them. And that's what makes this unique versus everything else that you see in climate science. Climate science doesn't follow the scientific method. It follows more of a political campaign. And the models simply don't confirm. The models aren't confirmed by empirical evidence is what you're telling me. And we're going to go take a look at all those things, right?
Yes.
So once again, this is a slightly long video, but you're telling me this is a great science fair project for people in high school.
Yeah.
And, you were telling me you're doing some expert witness, and this would be really good to show in a court of law if you're dealing on any global warming lawsuits.
Yeah, it probably would.
Okay, well, let's go take a look here. And the stuff we're going to be covering today may sound like total nonsense because of what you've been told, but when we were doing this, when you were doing this research, you told me that you stumbled upon something, and here it is: long-term instrumental and reconstructed temperature records contradict anthropogenic global warming. Now, you're saying anthropogenic is man-made?
Yes.
Okay, and so what you're telling me is there's research out there that's going to validate what you're about to show the viewers. The other thing is you're telling me try to get this thing shown in every science classroom out there that you can. Most teachers won't show this because it totally debunks global warming. But if you can, sneak this video around to all the students in your classroom that really want to know what the truth is. All right, so let's go on down here and let's take a look. What exactly do you mean the models aren't supported by empirical evidence? And this is what you're telling me. This is a report done by Dr. Spencer, and you can see Dr. Spencer and Christie, I believe, and you can see these are all the computer models, right? And these are down here are observations. And what you're telling me is that the observations down here aren't supported by, or the models aren't supported by these observations.
Yes.
Right? The models are telling you temperatures should be going higher, but the actual observations are basically staying flat.
Yes.
Okay. Now, in what you're telling me in normal science, when you get results like this that are this horrifically off, normally what you do is you go back and change the model.
Yes.
Right. But what you're telling me in climate science, what they do is they go back and change the data so that the model becomes more accurate.
Yes.
That's kind of backwards.
Yes.
That's almost fraud, right?
It is wrong, yes.
And it sounds like it's kind of an outrageous claim, but you're going to show me some stuff that pretty much supports that.
Yes.
Right?
I have some evidence.
All right, great. The other thing we want to cover is and you're saying quantum physics of the CO2 molecule. And what you're telling me is that this is an example of the absorption of, you said, long-wave infrared radiation between 13 and 18 microns?
Yes.
Jeez. Okay, so this is really impressive stuff. And what that means is at low levels of CO2, it absorbs a lot of energy. But as the concentration of CO2 goes higher, it absorbs less and less energy. And you said that what this is analogous to is painting a window black. The first coat of paint blocks out 90% of the sunlight, and all additional coats of paint block out less and less.
Yes.
And so we're basically here, and this is basically approaching zero slope. And then you're saying this is almost like an asymptote. That's the word you used?
Yes, I did.
So what you're saying here is because we're at this part, more and more CO2 isn't likely to cause greater and greater increases in temperature, right?
Yes.
And that's important because of what's about to come up, right? And we're going to cover that as well. So remember this, the quantum physics, when we get to some charts. All right. The other one is the thing we're going to cover is the urban heat island effect. And as you can see, this is a graphic of the what's called the urban heat island effect. What that means is if you heat up a bunch of buildings, that's heated by visible radiation, not outgoing long wave radiation. So you heat this thing up, and it'll store heat for quite some time, and it'll get hotter than the surroundings, and it'll radiate that heat out for a longer period of time. And so you get these things called heat islands. And as you can see here, the heat island can be up to be, this is an example, of course, but it's 1 degree, 2 degrees, almost 3 degrees of warming, if my math is right, from urban heat island effect. And as you see, the further you get from the city, see this flat line? That's what you're looking for. You're looking for a flat line of temperature that's a true reading of temperatures not being corrupted by the urban heat island effect. And so we're going to later on we're going to show part of this experiment is we're going to control for the heat island effect, and that's what you call it, right? You're going to control for the heat island effect, and this is a controlled experiment that you really don't find elsewhere in climate science, right?
Yep.
All right. Well, let's go take a look at what you passed on to me. I want to see what you've got here. Okay, and so you've really been doing your homework, right? I mean, this is pretty impressive stuff. You went out, and we're going to show you how to get this data later on, but this is Beijing. Now, Beijing is probably one of the biggest and most rapidly developing cities in the world.
Definitely.
And what you can see is there is clearly an upslope in temperatures. Back here, you can see, starting around 11 and ending up around 14, and it gradually, continually increased over the last 100 years. And this is once again Beijing. Now, you tell me for this science fair project, this scientific experiment that you're doing, you have to define what's called an uptrend, right?
Yes.
And you said an uptrend is a series of higher highs and higher lows.
Yep.
So this low is above this low, is above this low, is above this low, and then this high is above this high, and this high
It just keeps
is
going
above,
higher and higher.
okay? And so you have a defined mechanism by which you can define something as an uptrend or downtrend. All right, here's Central Park. All right, and once again, Central Park is a city, and it's developed. And as you can see here, if you use the unadjusted data, you're going from about 10.5 to 13, 10.5 to 13. And so you had a substantial increase in temperatures. If you use the adjusted data, you're going from 11.5 to 13. And so what's important here is remember that value. It's about 1.5 degrees Celsius. So according to New York City, which clearly urban heat island effect, temperatures increased 1.5 degrees. Now remember, you were telling me that the important thing about CO2 is there's two things about it. One, over the short run or for a snapshot, CO2 is a constant, meaning CO2 is the same in New York City as it is in West Point. West Point's just a little bit north of New York City. So you're saying in the short run, CO2 is basically a constant. But over the long run, CO2 becomes a variable because over this last 100 years, or we're looking at what Michael Mann did. He looked at temperatures from, we're going to be looking at temperatures from 1902 all the way up to 2000. And so over that about 98 years, temperature CO2 increased gradually. So over the long run, CO2 is a variable. Over the short run, it's considered a constant. And what that means is CO2 cannot explain a difference in temperatures between West Point and New York City because they're both being impacted the same, right? And so when we take a look at New York City, we have a clear uptrend. When we go to West Point, which is just north, and the way you can tell that because look this is north 41, this is north 42, this is west 74, this is west 96, but they're essentially in the same neighborhood. And if you look on the map, you can just take a short train ride going north to West Point. Okay, but when you go up to West Point, it's dead flat over the last 100 years. Matter of fact, this low right here is lower than this low back here. So in the 40s was warmer, the 20s was warmer, and it looks like the 1900 was warmer. There's no clear trend of uptrends. You do have this little spike here, but once again, CO2 can't cause spikes in temperature. It can cause an uptrend. But as you can see, this is pretty much straight as a board going over there. There's no global warming over the last 100 some plus years at West Point, which is just north of New York City. So you have a clear distinction between the two. Okay. Buenos Aires, once again, here, once you use the unadjusted data, and Buenos Aires goes from about, what is that, about 15 and a half to 18. And so you get 2.5 degrees of warming there. But look what's right next to Venezuela, or what was that? We were just Buenos Aires. Okay, you've got Buenos Aires right there, and then you look right next door to it, and you get this thing called La Estrazuela Illy. Okay, and that's pretty much flat as a board as well. These peaks higher than these peaks. You got a couple of clustering peaks here, but it's above this peak. These lows are all basically the same level. These peaks are maybe a little bit higher, but not substantially higher. And you did so you wanted to show everyone on Google Earth how to use this, and I thought this was pretty doggone fascinating. Okay, and so here's Buenos Aires, right? And this is where we're looking at the one weather station. And then we go right across the bay. Let me back this up a little bit. Okay, and there's the other one. So we have two weather stations. This weather station shows no warming. This weather station shows substantial warming. And what's kind of cool about this is with Google Earth, you can zoom in and see where they have that little thing placed. And they placed it rather proper. There's a road here, and so there could be some warming due to this stuff. But the weather station itself is in a nice little wooded area, and so that's relatively reasonable. And so you can understand why the temperatures are relatively flat there. Now what's funny is let's go take a look at what they did in Buenos Aires. Okay, and once again, right here, up here is the location identified on the weather station, and let's go take a look at where they put this weather station. Okay, this is literally, that's not a joke. That's not a joke. Okay, this thing is in literally, okay, you can't get a place that's probably absorbing more heat than this. And so, of course, you're going to have some warming there because, you look at what it's built around. So that's a great example of the misplacement of these weather stations and how they can impact. Now, what we're going to show later on is how we're going to do our scientific experiment is we're going to go find all the weather stations that are controlled for the Eat Island effect, like we just viewed, and then we're going to count up how many of them actually show an uptrend. Now, we, just to kind of like cut through the chase, we already did that. You said you already did this, and how many were you able to find that had an uptrend controlled for the urban heat island effect?
Not a lot.
Well, not a lot or zero. I thought you were telling me there was zero.
Yeah, there were not. There might have been more than
I think
zero.
Didn't you tell me you had you found 61 of them that had temperature records going back before the 1902, and none of them showed an uptrend. Some of them had like short-term trend, but none of them showed what would be clearly defined as a trend.
Yes.
All right, now this is now you said you wanted to give a little bit of history to the viewers where all this comes from. All right, now this is you were telling me is the 1990 IPCC temperature chart, right?
Yes, which is the Intergovernmental Panel of Climate Change.
Okay, and this is figure 7.1. Now, what I found impressive about this, and I'm not the scientist like you are, but this gives three different charts. It gives the last 800,000 years plus, it gives the last 10,000 years, which is called the Holocene, and it gives the last 1,000 years, right?
Yes.
And you were telling me that this this tremendous variation in the temperature over the last 100,000 years can't be due to CO2 because CO2 doesn't swing around, right? Yep. The other thing you were telling me that was really interesting was that temperatures peak when CO2 peaks. So ice ages start when CO2 is at a peak, and ice ages end when CO2 is at a bottom. So that's the exact opposite of what you'd expect from a global warming.
Yes.
You'd expect just continued warming with CO2. Well, you don't find that, and so CO2 cannot explain the temperature variation over the last 800,000 years, and it certainly can't explain why ice ages start when CO2's climbing and why ice ages end when CO2's falling. So how can you have a settled science when you can't even explain the basics? The Holocene here is, since the end of the last ice age, and once again, there's this tremendous run-up in temperatures that wasn't due to CO2. CO2 didn't increase before temperatures to end the Holocene, or to bring us out of the ice age and into the Holocene. And then you clearly have something called a Little Ice Age, and then you have something called the medieval warming. Then you have something called the Roman warming, and there's also a Roman and a Minoan warming here. And then you have a Holocene maximum. And what you were telling me is why this is so damaging is the current temperatures are well below the Roman and medieval warming period, and certainly well below the Holocene max. Yet we are at supposedly record high CO2 of the Holocene, so there's no way CO2 could be causing the temperatures to reach to cause this change, right? Because if it was, we'd already be at record temperatures.
Yes, definitely.
Okay, and then we go down here and we just look at the last 1,000 years, right? And as you can see, you can kind of see here that we have current temperatures, right? And then you have current temperatures well below the medieval warming period and well above the Little Ice Age. We're basically at the normal temperature for the last 1,000 years, right?
Kind of in the middle.
Kind of in the middle. So what you're telling me is this caused a real problem because this was published in 1990.
Yes.
You can go download this.
Yes.
It's in the IPCC report. The problem is this didn't support the climate change hysteria, right?
Yes.
This when you look at this, you say, well, CO2 is not causing any problems. It's normal temperatures, so what's the big deal, right? That's what anyone would reach. So you were telling me, so what you do in climate science is you don't go back and re-examine your model. What you do is you change the data.
Yes.
That's what you do?
Yeah.
That's kind of like science and that's backwards, right?
That's wrong science.
That's weird science is what that is. And so this is what they did. This is in I think the 2000 IPCC report. This is called the hockey stick chart done by Michael Mann. And what was weird about this is, first of all, you've got almost 1,000. You got 900 years of declining temperatures.
Yep.
Right. 900 years of declining temperatures. Whether CO2 went up or not, it went down. But there is no medieval warming period. Is no Little Ice Age. But what you told me is right here is the smoking. Well, the other thing is all this data is what's called proxies. You said.
Yes.
This is tree rings, ice core, and coral. There's no thermometer data.
Yeah.
Isn't that weird?
Yeah.
Okay. And then here you add the thermometer data and it dog legs, and then you drop the proxy data and it goes up even faster.
Yes.
And so you said that this is a smoking gun. That first of all, the behavior of the chart changes exactly when they change the proxies or the construction.
Yes.
But you also said there's nothing about the CO2 trend at this time period that could have justified such a sharp rise. You said that the quantum physics simply do not justify a sharp rise in temperature at these levels, right?
Yes.
You're saying that the temperature or anything should kind of like maybe flatten out, but it would never dogleg because of quantum physics. You know, it's like you're putting your 6th or 7th black coat of paint on the window. That's not going to do much. So, if you really understand the physics and everything, Michael Mann's chart actually debunks the theory that CO2 is causing the warming, and we're actually going to get to that. All right. Now, this one I didn't even know. This is something that you brought to my attention that I thought was absolutely fascinating, because you got to ask yourself, why would Michael Mann not include thermometer data when it exists? There's a temperature chart out there that goes all the way back to the mid 1600s, right? It's called the Central England temperatures, right? And this is the granddaddy of them all, they tell me, or you were telling me. And as you can see, since the mid 1600s, there was variations in temperatures, but there was no
Huge
uptrend
spike,
in temperature.
yeah.
Okay, but you were saying what was really odd about this, and it's similar to the hockey stick chart, is that it seems to do a dog leg, and if you draw this in 1975, it just dog legs, right? And you were saying that once again, there's no explanation why CO2 would cause this. So even though you have warming, CO2 didn't suddenly rapidly change in 1974.
Yep.
Right? But you're saying you can just look at this and say something seriously went wrong in 1974, and you did a little digging, from what I understand, and you found out that sure, there's other charts out there of Central England, and it shows no warming. I mean, you've got you got this chart shows the winter, spring, summer, and autumn, and there's no warming here. Right there looks like the peak, and that's in the mid 1800s. There's another peak here, but once again, there's absolutely no trend. And so if you would have, if Michael Mann would have included this in the hockey stick, he would have shown no warming over the last 100 years.
Yes.
Okay? Same thing with the mid temperatures here. There's a little bit of warming here, but then it looks like you have a little cooling here, and then you have no warming here. But there's this little oddity stuff here that kind of at this very end, the behavior changes. And once again, there's no reason CO2 would suddenly change in 1974. Well, you did some digging, which I find absolutely fascinating. How dogged you are about this stuff. And lo and behold, look at this. They changed the construction just like the hockey stick. They changed the construction in 1974. and it's suddenly dogleg. Now, this is what you were telling me in another video, that you didn't want to include stations by the water because of something called a PDO or a ADO or an El Nino or La Nina can dramatically change the temperatures around those areas. But look here, they're continuing. This tells about the construction of it, and the construction was identical up until 1974 when this Manley person passed away. And then he says, 1974 onward uses observations from a variety of stations in England Midlands, including the South Midlands. Okay, South Midlands, you would think south would be a little bit warmer. Neither Oxford nor stations on the Lakeshore Plain have been utilized, so they kind of like cut some out. But here's the interesting one. For 30 years, one coastal site was included. It is therefore manifestly not the same series. So the series pre and post 1974 are wildly different. But they don't bother to tell you that, and they don't broadcast it. You have to find these organizations that keep an eye on it, kind of like their whistleblowers. All right, and so once again, you've got two data sets here that have been manipulated. All right, but what's really kind of interesting is this. This was let me open something up here real quick. You did some more digging, and you found this PD Jones. He is he's the guy who works over at the CRU. From what you're telling, the CRU is the Climate Research Unit.
Yes.
And he did research on long-term temperature trends. Okay, and so Michael Mann totally avoids long-term temperature charts, and yet the person he knows very well did research on it. And what I find kind of interesting is when you look at all of the long-term temperature charts collected by Jones, Phil Jones, his name is. There's basically none of them showing uptrends. And so Michael Mann has a hockey stick that avoided using thermometer data. And when you go back and use the thermometer data that Phil Jones himself has, you would clearly have had no warming over the last 100 years or so. Okay? And so none of these temperature charts show a dramatic increase in warming due to CO2. Now, there's some of them that might have uptrends. There's some that have downtrends, but none of them show a dramatic uptrend. Okay. Now, the other thing is, so that was another set of oddities, right?
Yes.
They first of all, the long-term temperature trends don't show any warming due to CO2. 2, Michael Mann deliberately avoided it.
Yes.
3, the Michael Mann's hockey stick chart, which if you take a close look at it, shows about 1.1 or 1.2 degrees warming over the last 100 years. Okay, that's consistent with urban heat island effect. It's not consistent with CO2. But more importantly, now we're looking at NASA. So that was the CRU over in England. Now we're looking at some of the what's called the RSS data from NASA. And Dr. Spencer, if you're not familiar with Dr. Spencer, he has a nice blog. You probably want to check it. He publishes all the satellite data. You also probably want to go to Real Science, where Tony Heller does his work. And I got this off of, or you're telling me you got this off of Tony Heller's website.
Yes.
And what it is they somebody in Congress brought to the attention of the regulators that the NASA data doesn't support warming, right? And so they pointed out that the RSS data doesn't show warming, and that's deviating dramatically from the models, right? And so the moment they brought that to the attention, just like all this other stuff, NASA, the people at NASA had to figure out a way to kind of hide what was going on. And this is the one that really kind of fascinating. So you went and once again, this was the help of what Tony Heller at Real Science did this, and you went and verified it. And so you went, and this is to the RSS website, and let's just go up to the top here. This is the Remote Sensing Systems. It's remss.com/research/climate/ and this is climate analysis. So you can go check this yourself. And if you go down here, you'll see that they've got their temperature charts, right? And you see this black line represents actual data, is what you're supposed to believe.
Yes.
All right. I want to point one thing out here. See how it goes from 70 south to 80 north? This is going to be important here in a second. But when I look at this, it looks to me like the range of the computer estimates and their actual kind of fall in place. That looks to me like you've got a pretty good model, right?
Yes.
The only problem is that's garbage data. Because if you go to the Wayback Machine and you go to the Web Archive, before they had that congressional hearings, this is what it looked like. But this is, once again, they did something funny with the location. This is 70. The other one's 70 to 80. This one's 80 to 80. But what's important here is they have estimates of the actual values, and then they've got the model. And as you can see, the actual and the models are outside of each other here, right?
Yes.
And so if you take a real close look at what they did, they got rid of this band, and all they're doing is showing this upper part, which is, anyone knows, your 2 standard deviation outside. Outside of that, there's basically no chance of the temperatures actually being there. But that's what NASA uses as their actual values.
Yes.
And like again, I know that sounds outrageous, but you can just check it. There's 1, there's 2. Okay? Now, it is slightly different because I told you they dropped part of it off. The other thing that you were pointing out that's kind of interesting about this is go down here and take a look at this. That, to me, looks like a real connection. Okay, and this is water vapor and temperature. Now that's a tight fit. Okay, there's no problem saying water vapor and temperature are tightly related. They of course never mention that water vapor is the most significant greenhouse gas. Instead, they focus on CO2, which is nonsense, and their model doesn't work, so they have to fudge the data. When they got the answer right there on their own website, they just downplay that. Why? There's no money if water vapor is the problem. Okay. So that's something you're going to want to do in your science fair project. And so now once again, this was predicted this was back in 2007, once again by Tony Heller. So this is 2017, okay? And this change just recently occurred. And so if you read this, Dr. Spencer pretty much predicted what they were going to do, and in fact they did it. So that's kind of dangerous when a fellow scientist can say, look, NASA is going to fudge their data because the models aren't jiving with the actual values. And once again, that was done in advance. And once again, here's the examples. Okay, this is before, and this is after. And you can see all they did was they just simply used that upper band, which is total fraudulently.
Yes.
Total fraudulent science.
Definitely.
And it's pretty amazing that someone hasn't looked into that. Okay, now let's go take a look at what we've got for the falsifiable hypothesis. Okay, let's go take a look, and you're going to show everybody how to do their science experiment. Okay, now this is another one that you're telling me you need to do a kind of a hack into the NASA website.
Yes.
Okay, if you go to the NASA website now, it's version 4, and so if you go down here and you go down to this globe. And remember, we're looking for websites or stations that existed before Michael Mann's hockey stick chart started. So if you go here, and we always use the unadjusted data, and if you go here and you hit update, here are all the stations that existed prior to 1902. And in Australia, there's not one. Right here, it disappears. Okay. What you can do is you have to do what's called a hack, okay? And so you go up here and you change the address from where you are now. Just change the 4 to 3 and just hit a backslash. And look what it does. It brings you to the older version. So that's the hack that you need to know. Now, the other thing you have to do is you have to change the ending date back a little bit. You have to change it back to July. Then you can change this to 1902. Okay? Then you hit update.
There are not that many.
There are not that many stations, you're right, but there's one that's just absolutely a beauty. And right there it is, Australia. All right? And so Australia, you go here, and what you're looking for is a BI of 0. And you're telling me the BI means that it's shielded pretty much from the urban heat island effect.
Yes.
And you wanted to make sure that the years go back before 1902.
Yes.
And you want it to go to relatively current. Okay. And so when you do that and you hit that, there's Alice Springs. Now, NASA did change something on us. Now you can't see how this is what you want. You want the unadjusted. And so this is the unadjusted, and you can see there's absolutely no warming over the last 100 plus years.
Yes.
This is almost 140 years now of no warming.
Yeah.
Now, once again, CO2 increased from around 300 to 400 during this time period, and it had no measurable impact on temperatures, and it was shielded from the urban heat island effect. So what you do for your science fair project is you go and you just go shop around, and you find all the weather stations that have that are in the middle of nowhere, not coastal, that have a BI of less than 10, okay, or 10 or less, and then you print them off. And like since right there's one with a 0. So you hit this, and so what you do is that one actually looks like there probably was a little bit of warming. Let's see what the unadjusted looks like. It doesn't have it. Okay. And then you go down here, and what we did was we just simply printed off the PDF, or you save the PDF, and we had a collection of 62 or 63 of these websites. This one we didn't have in it because this one probably would have showed a little bit of warming, but you can see that it didn't really warm much. There is a slight trend here, but this one would have probably been recorded as a uptrend. Here's one. Let's take a look here. That one shows maybe a little bit of warming. Okay, but we collected 62 of these, and we were able to find none of them with significant warming. Now this one, once again, this is -2. You go -2, but still you're not increasing by a full temperature or so. You're going from a little bit under -2 to a little bit to -2. So even though there might be an uptrend, it's not a major uptrend. Certainly not to 1.25 degrees or 1.1 or 1.2 degrees by Michael Mann. So what you do is you just go and you find all these weather stations, save their PDF, print them off, and then just determine whether or not they show an uptrend or not. And then you count them. And when we did it, we basically found none of them showed a significant warming that would count as a significant uptrend, and none of them showed the amount of warming that Michael Mann shows in his chart. So we were able to quantify the fact that had Michael Moore controlled for the urban heat island effect, he would have basically showed no warming post 1902. And so his chart, if anything, does nothing more than register the urban heat island effect, not true global warming due to CO2. Now that's a hypothesis that you can go test using NASA's own website.
Yes.
The other thing is, you were telling me you've got another way to test scientifically. What you do is, and you can actually reject a null using statistics of plus or minus 2 or 3 standard deviations. So you can go, 95 or 99% confidence. Right? And what you said was what you need to do is you need to go and download the Vostok ice core data. That's right?
Yes.
Okay, so you download the ice core Vostok ice core data, right? And what you want to do is you want to isolate the period of the industrial era, and then you want to isolate the period of the remaining part of the Holocene. And what you'll find is if you measure the temperature variation in the mean of the past 150 or so years and the standard deviation of it, and you compare it to the mean of the rest of the Holocene and the standard deviation of the rest of the Holocene, you'll find that there's nothing abnormal about our temperature. And that way you can literally use science and the statistical methods to either accept or reject the fact that man has had no impact on climate. And you'll find out that you do not reject that. The other thing that you can do is you can run CO2 and temperature, and you can lead and lag your data variables. And what you'll find is that the highest correlation you get is when you, let me make sure I got this right because it's always hard to explain. You wanted to line today's temperature with CO2 from what was like 800 years ago.
Yes.
And so what you do is you lag temperature 800 years. And so what you found is that the greatest correlation is when you tie today's temperature to CO2 800 years ago. And what that means is you lagged temperature. And so what that means is temperature increases before CO2. And you're telling me that makes sense because of Henry's law.
Yes.
Because Henry's law, you first have to warm the oceans then release CO2, and then it increases. Now, this is an example of, it looks like you've got a couple charts here of what's called Law Dome, and this is Vostok. Okay, and so that's your science fair project you were telling everybody about.
Yes.
The first one is go to NASA, download all the websites that have a BI of 10 or less and existed prior to 1902.
Yes.
And then quantify whether or not they have an uptrend or not, and then see, can you accept or reject the hypothesis that or the urban heat island effect is what's causing the warming.
Yes.
And then the other one is, does it compare to Michael Mann's hockey stick chart? Can you find any charts with a BI of 10 or less that existed back then that increased by over 1.1 degrees? And what we found is that you simply cannot. The other one is to download the ice core data and just simply verify that the mean and variation of the past and during the industrial age is not significantly different from the mean and variability of the rest of the Holocene. You'll find out that our current temperatures are just simply normal, and that's according to ice core data.
Yes.
Then once again, you lag the temperature, run your regressions, and find out which one has the highest R squared. And what you'll find out is that the highest R squareds occur when you're lagging temperature by about 900 to 1100 years.
Yes.
You do that science fair project, you show this to your science teacher, and finally you'll be able to bring real science to climate science. And when you do that, what do you find? CO2